This video is an introduction to data processing within the AcousticTag program. Topics to be covered: data file types, tag positioning settings, tag selection, performing tag positioning, and viewing tag positioning results. So here's a diagram of the various phases of data processing, where we have AcousticTag. During data collection, stores the raw AcousticTag signals within a RAT file. These files are then read into mark tags, where these signals are then assigned a tag ID, which is essentially the ping rate or period of the tag, as well as the subcode if it's a double pulse tag. These tag detection files can then be used either for survival studies, where along with bookmark files, time-stamped tracked files, and some summary files can be used for evaluating presence absence, migration routes, or predation events. For behavioral studies where you're monitoring or evaluating fish aggregate devices and predation events or structure avoidance, the track files are read into AcousticTag, where a data database is created that has the tracked information as well as the tag positioning results will be stored within a database. So here again, we have tag detections and mark tags on a per hydrophone basis. That data is read into AcousticTag, where based on the known hydrophone positions, a tag position is then calculated, which results in a track of the tag within the various displays of AcousticTag. So let's here start the program up. And the very first thing, as always done, is opening up a project database. So under Project Open, we open up database, and under Setup, hydrophones, here we have the known hydrophone positions, which are usually in Universal Transmercator or UTM coordinates. That's the most flexible coordinate system. The AcousticTag program is unitless in the sense that whatever coordinate system you choose, it can be either in feet or meters. But once in a specific unit, the units have to be used throughout the program. So once you have the project database opened, you then need to view the grid area origin defined for this project site. Here we have the scene window where we can move up and down in the area of the hydrophone array. Now, the grid area origin is important because any tag positions will be restricted within this grid area. And this is in order to prevent unnecessary calculations when performing tag positioning. The grid area can be set through the position display dialog box. The origin should always be set below the deepest hydrophone in the array. And then once that's set, you can set the dimensions of the grid. For example, if we wanted to increase the z-axis, we could change the number and hit apply, and that changes the grid area. Or we can go back to our original. So again, this would be important because of any calculated tracks will be limited within this grid area. So if you have a scene of the area, you can open up this time. So once the scene is open, you toggle the map button of the main toolbar. And here we have a georeference map of the project site. You can also open up a view file, which allows you to store a previous zoomed area of the site. And here we have our displays of the symbols for hydrophones. In fact, if you click within a symbol, It'll tell you the label and hydrophone number. You can do so the same here on the graph window, where you can click on the label and it also gives you the positions of that hydrophone. So once this is opened, we can then make a database. So under Data, New, Database, here is a tag detection file. We select it, and if you use the Copy Name button option, it fills in the name of the database that will be created with the same name as the TAT file. You can also define where the database is to be stored. So once we have it set, we say Create, and now a database has been created that contains the tracked information from the TAT file and is now ready to calculate tag positions. But before we do so, we need to go over the settings that we've applied for each tag within the database. So each section here we'll go over. Overall settings. Here we have two main options, is positioning 3D or positioning 2D. And for the 3D option, it will calculate a X, Y, and Z position for a tag, where the tag must be seen on at least 4 hydrophones to calculate a 3D position in the X, Y, Z. If you don't have enough range in the depth of the hydrophones from the surface to bottom mounted, you can also do a position 2D, where a calculated position of that tag will be done only for the X and Y position and not the Z. For this case, then a tag must be seen at least 3 hydrophones to calculate a 2D XY position. We also have an entry for a minimum number of detected signals. This is where in the marking phase of mark tags that we ensure that we have enough detected signals to calculate a position. And so there's a number that you can apply there. So here is a representation of the 2D and 3D tracking, where the first graph here has just a single hydrophone, where you can again do presence-absence type of processing. For the 3D, where we have surface and bottom mounted hydrophones, that if there's enough separation between their surface and bottom, we can calculate a Z position. In a riverine system, where normally the water is not deep enough to calculate a depth, we then have hydrophones placed on the same plane, where then we would just calculate an X and Y position for 2D tracking. So now we have a before positioning section. These are the settings that we applied on a per hydrophone basis before a tag position is calculated. And this is to ensure that when we are calculating a tag position, that we will eliminate any multipath data which can affect the precision of the position that's calculated. So for hydrophone tracking maximum gap, here is a display where we have a series of tags, signals that were recorded from that tag. And if the gap is small enough, then it will put in missing returns within these line of signals. If the gap is too large, then no interpolation will be done between this section. For fish swim speed, this is used to make sure that we don't have any outliers, basically, of the signals for those series of signals coming from that tag. And so if the calculated speed, basically, can the fish swim this far away and then back again? If not, then this signal will not be used for calculating the position. Time constant will smooth out the position of the tag to make the track more in line. Next, we have under solution, first and multiple option, where the first only calculates positions of the nearest 4 or 3 hydrophones as the tag is moving through the array. The multiple option will use a combination of hydrophones for calculating the position. For geometry type, we have ignore, which uses any combination without regard to hydrophone location geometry. And require would then make sure that the hydrophones are not within the same plane. For example, if a tag was seen on these three hydrophones, first, if we set the ignore, then we would not want to have the calculated position based on these hydrophones since they're in the same line. We want to ensure that a hydrophone separated far enough will be used in order to calculate a correct position for that tag. So next section is after positioning, where tag positions have been calculated, and these settings are then applied to those position signals. So we have an interpolation where if there is a gap between the data in terms of the calculated position signal, it will be filled in with signals for the distance that you have defined in time. If there is a main change in range, then again, if it's too far in terms of the space that you have defined here, then the signal will not be interpolated. If it is within the expected position, then the interpolation will be applied to that area of the track. And the smoothing. It will smooth out the track of the tag to better represent how that tag went through the array. Next, we have under transit a normal and advanced option. Normal will restrict the calculation of position signals within the array. Advanced allows calculated positions to be calculated outside of the array. So this would be in the situation where if the fish traveled outside of the array, for example, near shore here, then we would want to have the advanced option on in order to calculate those positions. For normal, it'll be restricted within the array itself. Transmit window. This is where the delays from the hydrophones are calculated and compared to what's expected based on the hydrophone positions. So if you're confident of your positions of your hydrophones and you have not moved throughout the project, then this number can be 1 or 2 in terms of the calculations and the comparison made. If, for example, a hydrophone was hit by some structure within the project and you were unsure of the actual position of the hydrophone, then you might need to increase this number in order to calculate positions for that tag. And finally, we have a number of solutions for calculating the center clusters. This is an iterative process where you can limit the number of iterations that the program uses for calculating the best calculated position for that tag. This is really an option that was used for slower computers, which nowadays is not really necessary. Okay, so now we've gone through our settings. Next option under tag positioning is tag selection. Now this dialog box shows all the tags that were marked within that tag detection file. And so by default, they are set for use in tracking. Now this list of tags is different than under the setup tag information dialog box. This list of tags is only used for real-time tracking, where in post-processing, this is the list that will be used for calculating tag positions. So now we have sequence selection, where essentially each tag detection file that is read into a database, which can be any number of them, which usually each TAT file is an hourly file. So whenever you read in a TAT file, it is now defined as a sequence. So a database can have any number of TAT files or hourly files within the same database. So you first select a list box entry, which is only one here, and then we select perform positioning. So it calculates the positions for the tags within our list. On the main toolbar, we have a select tag control where it shows you the first tag results within our list, which we see here is a tag that did not move within the array too much. So we can zoom in and see the results from that track. Let's go to the next tag in the list. So here's a tag that went through the array for this hour. Once we have it displayed, there's some information that we can obtain from the track. So under Position, Signal Information, displays the Position Signal Information dialog box. So you can zoom in, and you click on a position signal that was calculated. It fills in the dialog box with the tag ID, the date calculated for that position signal, the X, Y, and Z position, which for the hydrophone, and then the hydrophones that were comprised for calculating this position signal. Oh, these are the actual X, Y, and Z positions for that signal, and Z is always a constant for the 2D tracking. You can do the same thing for the georeference map display, where you can click on a position signal and it updates the dialog box, where the date here is 23/30/59 was the last calculated signal for this particular hour in the tag detection file. So we can hide that. Another option is to animate this track. So under Display, Tag Position Options, we turn on the Video On option. We can set a speed, and doing so, this enables these video type controls on the main toolbar, where we can click on the play forward, and it will show you the track of the tag as it went through the array. Now, this is not the actual speed that the fish travel through. It's just the animation of the track based on playback speed that we've defined. But you can get some idea of how the fish traveled through the array using this animated option. You can stop at any time, and you can play it backwards, or you can go all the way to the beginning or the end. And then turning that option off displays the track once again. These settings can save to a file. So we have a track file that we recorded, saved, so let's open that up. So these are the settings now that are all updated based on the file contents. So the next option is for tag selection. Now this dialog box is automatically filled in with the tags that were detected within the tracked tag detection file. Now these entries are automatically set to be tracked, all the tags within the file. Now this list of tags is different than under Setup Tag Information dialog box. These lists of tags are used for the real-time tracking option within AcousticTag. So now we have tags that will be used for tracking. Next is sequence selection. This dialog box displays for each tag detection file that is read into the database, which there can be more than one. It's defined then as a sequence. Basically, each TAT file is an hourly file, so each entry can be another set of data for that tag on an hourly basis. So you select the entry, which is only one here, and To perform tag positioning, you select the Perform Positioning button. So it calculates position for each tag in our list. On the main toolbar, there's a Select Tag control where it always displays the first tag in our list. So this tag seemed that it did not move much within the array for that particular hour. You can zoom in and see it stayed in basically the same position. Next in our list is tag 6519, subcode 19, where it went through the array for this hour. Now we see down here that we have some gaps within our tag positioning results. So let's go back to our settings and let's apply some interpolation to the position signals after they've been calculated. So let's say that to 20, to 5, to 3, say OK. So to recalculate tag positions, you go back to the Sequence Selection dialog box, select the entry, click the Delete Sequence Position Results, and then to recalculate, just select the Perform Positioning. And here again we have our tag 5203, which is saved in the same spot. And then the next tag in our list, we see now that we have a much smoother track of that tag based on the interpolation settings that were applied. So once we have the track displayed, we can obtain some information for that tag. Under Position, you can select the Signal Information menu option, which displays the position signal dialog box. So in the graph window, if you zoom in and you click on a position signal, it fills in the contents of the dialog box with the numbers for that position signal. We have the tag ID, the date for that calculated position signal, the XY for that signal, and what hydrophones were comprised in calculating this position. You can do the same thing within the map window where you can click on the last signal calculated and it updates the information in the dialog box where the last calculated signal for that tag for this hour was 23:33:59. Another option for viewing the track of this tag is under Display, Tag Position Options, we can enable the Animate feature, where if we set a time factor, this enables the video control type buttons on the main toolbar, where if we hit play forward, it plays back the trace of that tag for this particular hour that the tag was tracked. You can pause it, you can play it back, pause it, or go one signal at a time, go back a time, or if you go back and turn the option off, it shows the entire track again. So this completes the introduction to data processing within the AcousticTag program.